These are notes for objective 1.9, use a calculator to find and evaluate a linear model, part 2. We're going to work on evaluating a linear model, meaning judging whether it's good or not. Linear models only work when the data that you have is actually linear. If the data is not linear, you can make a model of it, but not a linear model of it. And though the calculator will give you an answer, that answer will be meaningless because it's not actually linear data. And the best way to tell whether data is linear or not is to look at a scatter plot of that data. And you can see several hypothetical scatter plots here. This one right here is linear data. The data is grouped together in a pattern that tends to go upwards with a straight line. Something like that. Now that's not the exact line, right? But that's the general trend of the data. There's a pattern to it and it's in a straight line. That is linear data. This data over here is nonlinear. There doesn't seem to be any pattern to this data at all. So I would say that this is not or non-linear. In fact, I think that there's no pattern here whatsoever, but it's definitely non-linear. This one over here has a pattern. It seems to be going outwards this way and then it curves upwards. The fact that it has this curve to it makes it also non-linear. If it's got a curve, it's not a straight line. And this one also arcs up and then back down. It's got a curve, so it too is non-linear. When you've got that scatter plot, it's easy to see whether data is linear or non-linear. If you have a set of data in a table, though, it's somewhat more difficult to see with your eyes. So instead, we can use our calculator to find or to make a scatter plot so that we can look and see if the data is linear. We'll start with data from A here. And in order to do this, I need to make sure that my data is in the calculator. You guys have done this before, just like when we found the regression. Go to Stat, Edit, clear out your data, and enter your X's into L1 and your Y's into L2. Like so. From there, we need to make sure that the stat plot is turned on. Go to Second, and then hit Y equals, and that will take you to the stat plots. There's 3 listed, 1, 2, and 3. I see that stat plot 1 is on, so I'll select it and just make sure. If it were off, you could move the cursor over here, press enter, and turn it on. We want it to be on, and we want L1 and L2 right there. So we have that on. Now we want to actually make the graph. Go to Zoom and scroll down until you see Zoom Stat right there, Zoom Stat. That will give you a good window to look at your data. You can either press enter or hit 9. We see there that the data looks like generally a line. It goes up in a straight direction. So this data is linear. Rather than walk you through each individual data plot, I'll indicate what they look like and whether they should be linear or not linear. So this data plot looks something like this. And that's non-linear. This one looks something like this. It's got a curve to it. Some people might think it's a subtle curve, but there is a curve, so non-linear. And this data is all over the place. No pattern, so definitely non-linear. On the back, we're now going to think about what the slope of a model means. Example 2 says, write the linear model for the data below, and then write a sentence to describe the significance of the slope. So first off, we'll find the linear model here. You guys should be good at this by now, but the basic idea is stat, edit, put your data into your calculator. 0, 2, 3, 4, 5. And then the y's in L2. 3, 9, 10, 14, 15.5. Stat calc and run a linear regression. You can see that the linear regression is 2.5 is our slope and 3.2 is our b. So that equation is y equals 2.5x plus 3.2. Now I want to write a sentence describing why the slope here is important, or what the slope means. A model for this sentence right here is each week that passes, and I get that from right here, the units of my x. Each week that passes, the dog, well, the y that's changing is the weight of the dog. So each week that passes, the dog gains some weight. How much weight does it gain? As much as is indicated by the slope. Gains 2.5 pounds. In general, you could say that you can think of slope as each time x changes by 1, y changes this much. And this much comes from the slope. That's where you get how much it actually changes. Down here, we can do the same thing. Find a linear model and then write a sentence to describe the significance of the slope. The linear model ends up being y equals negative 30x plus 200. If we're going to write a sentence for it, we write it in the general model. Each time x changes, y changes this much. So each time x changes, I see that x here are my months. So each month, you could say each time a month passes, or each month that goes by. Y changes. So my y is the money that Imari has. That's going to change. By how much? I find that in my slope. I see that Imari's money is going to go down $30 each month. So each month, Imari loses $30. Again, each x, y changes this much. Each x, y changes this much. And this much comes from the slope. So that's both how to decide whether a linear model is a good model and how to write a sentence describing the significance of the slope.